Hello, Honors Pre-Calc. This is the lesson for Wednesday, January 26th. We're continuing our exploration of trig identities and their uses to simplify trig expressions. So before I get started, I just want to remind you that the homework is packet page 9, problems 27 through 37 odd, including 47 and 49. These will be due tomorrow, as well as the homework that I assigned on Tuesday, January 25th. I'm starting today's lesson on packet page 3. On packet page 3, there's a whole list of arithmetic operations that we didn't go over in detail. But before I started doing some more of our problems with simplifying our identities, I wanted to point out that the top of page 3 in the packet goes over some of our fraction rules that you may be struggling with for a long time. Maybe you just need a quick review. But if you look at the top of page 3, you will see a very quick review of fraction operations to help you with our trig identities and our simplifying. So we're going to continue where we left off on page 6. On page 6, there are problems that we didn't do, and those are the ones I'm going to focus on today. The instructions for this are on the previous page. They say simplify to a number or a single trig function. So when I'm looking at E, I see two fractions, and normally in these kind of problems, when you see two fractions, you need to combine them in order to simplify to a number or a single trig function. The first thing I did was I changed cotan squared beta, that B is beta like the Greek letter. I simplified cotan squared beta to cosine squared beta over sine squared beta. So that's one of our quotient identities. And then when I did that and simplified that second fraction, I was able to have a common denominator. For these problems, a common denominator is crucial in order to combine the fractions and simplify. From there, I combine the fractions. Since I had a common denominator, I'm allowed to subtract the numerators. When I subtracted the numerators, I noticed that 1 minus sine squared beta is from our Pythagorean identities. The substitution can be cosine squared beta, so cosine squared beta divided by cosine squared beta is 1, so we've got it down to a single number. Letter F has a single fraction, but it has two trig functions, and we need to get it to 1. So for problems like this, I'm going to try to get it all to tan, at least in the very beginning. And the way I'm going to do that is I'm going to use the reciprocal identity for cotan x as 1 over tan x. And then I notice that my denominator, the first fraction in pink, that denominator is now pretty complicated. So before I simplify the entire fraction, I need to simplify the denominator by getting a common denominator. So I'm going to multiply the 1 in the denominator by tan x over tan x. So the denominator is now tan x over tan x plus 1 over tan x. And just as in problem E, I can combine the numerators if I have a common denominator. So when I do that, I am able to now simplify the entire fraction. I always use the phrase keep, change, flip to simplify complex fractions. When I do that, I can see that I can divide out 1 plus tan x divided by 1 plus 1 plus tan x, I can divide by tan x plus 1. Those are the same. Remember that addition is commutative, meaning I can change the order and it's still the same. And that only leaves tan x over 1, which is a single trig function, tan x. Down to letter H. Let's see if I can fix this so that it's, there we go. I just want to make sure you could see everything on my screen. So for letter H, my hint for problems like this is if it's already in factored form, you need to put it in standard form by multiplying, either by FOIL or box, however you do it. So multiply the two binomials. When you do that, you get 4 terms. And since they are conjugates, meaning cotan x plus cosecant x is being multiplied by cotan x minus cosecant x, when that happens, there is no middle term. When there is no middle term, all I have left is cotan squared x minus cosecant squared x. And because I have that, I can use my Pythagorean identity of cotan squared theta or cotan squared x plus 1 equals cosecant squared x. So I'll make that substitution for cosecant squared x, in which case in red I now have cotan squared x minus cotan squared x minus 1. Remember to distribute that negative sign. Since the cotan squared x's, they subtract to be 0, my final answer is a single number, -1. Letter J. Once again, I need a common denominator. To do that, I need to do what we've done in the past, which is basically a least common multiple or least common denominator. So that means I'm going to multiply the first fraction by cosine x over cosine x. I'm going to multiply the second fraction by 1 minus sine x over 1 minus sine x. That gives me common denominators for both fractions. Keep the denominator in factored form. If we're trying to get it to a single trig function, we're going to have to do some cancellation or divisions between the numerator and denominator, and keeping it in factored form will let you see those divisions or cancellations to eliminate. So once I have the denominators the same, I can put both fractions over a single denominator, and I notice on the numerator, because addition is commutative, meaning I can change the order, rather than have cosine squared x minus sine x plus sine squared x, I'm going to change it to cosine squared x plus sine squared x, and notice that is one of our identities, the Pythagorean identity. So I'm going to change that to 1. Cosine squared x plus sine squared x equals 1 is what I'm going to substitute in. So now my numerator is 1 minus sine x. The denominator is still cosine x times 1 minus sine x. And because we kept the denominator in factored form, we can divide out 1 minus sine x divided by 1 minus sine x so that we have eliminated the factor numerator and denominator. Remember, when you get rid of the entire numerator, it does not leave 0, it leaves 1. 1 over cosine x is a single trig function, but you, generally speaking, don't want to leave the trig function in the denominator. You want to change it to the reciprocal trig function, which happens to be secant x. So I have it down to a single trig function. And I think the last one I'm doing on this page, let me make sure. Yep, we already did, I believe, B yesterday. So for example 2, the instructions are different. Rewrite the following expressions in terms of sine x. So I have to make sure that whatever form of sine x, any form of the final expression I'm left with, it must be in terms of only the trig function sine x. So the first thing I did in example 2a is I started to change things to be sine x. For example, cosecant squared x is the same as 1 over sine squared x. That's a reciprocal identity using a power. Same thing with cotan squared x. Cotan squared x can be changed to a quotient identity, cosine squared x over sine squared x. Now, of course, because I have a common denominator, I can combine the numerator. When I do that, I notice with cosine squared x, I can put that in terms of sine squared x by using my Pythagorean identity. This is one of the Pythagorean identities that you'll have to flip around a little bit in order to do the substitution. Since cosine squared x plus sine squared x equals 1, 1 minus sine squared x is the same as cosine squared x. So 1 minus sine squared x is what my substitution is in the numerator. So when I simplify the numerator, I end up with 1 plus 1 is 2 minus sine squared x over sine squared x. Of course, I cannot just divide out the sine squared x without separating the fractions again. So sometimes you have to combine the fractions and then separate them again. In this case, we didn't really start with a fraction, but we had a combined fraction that we now need to basically separate again into two separate fractions. The reason for that is I can only divide sine squared x into sine squared x. So if I make that its own fraction, let me just move this window so you can see it better. There we go. If I separate sine squared x divided by sine squared x, I can change that to be, if I simplify that, it simplifies to 1. And now I really do have my entire expression in terms of sine x. It's 2 over sine squared x minus 1. Unlike the previous problem where I got rid of the trig function in the denominator, since it has to be in terms of sine, I'm going to keep that expression that I circled exactly the way it is. I'm on page 7, and to do page 7, my first hint is that you need to use what you know about conjugates. So if it says rewrite 1 over 1 plus sine x so that it's not in fractional form, multiplying by a conjugate, which would be 1 minus sine x over 1 minus sine x, gets rid of that denominator so that the trig function is no longer in the denominator. It looks like I'm going to have to expose the whole thing even though I have it in 2 rows. Well, I can go like this. Here we go. So multiplying by the conjugate. You can't just multiply the numerator or the denominator by the conjugate. You must always multiply fractions by 1. So 1 over 1 minus sine x over 1 minus sine x is 1. In the denominator, that changes it to, if I use FOIL to multiply, 1 minus sine x plus sine x minus sine squared x. Notice again, I'm using the conjugate to get rid of the middle terms. So I'm left with 1 minus sine squared x in the denominator. The numerator simplifies to, well, since I just have 1 times 1 minus sine x from the beginning, I'm only left with 1 minus sine x. So what I'm going to do here is, since I don't want it in fractional form, I am going to use my Pythagorean identity to substitute 1 minus sine squared x with cosine squared x. From there, again, I am separating the fractions. I am separating the fractions because I don't want any trig function in the denominator. If I separate 1 over cosine squared x and make it, oh, I have it as multiplied. That's not right. It should be subtracting. Here we go. Sorry, that's subtraction. when I separate the fractions, I can change 1 over cosine squared x to secant squared x times 1 minus sine x. And notice how I no longer have a trig function in my denominator anymore. Okay, so notice in red I wrote stop when there's no fraction left. So secant squared x times 1 minus sine x is no longer a fraction. Example 4 asks us to combine the fractions and simplify to a basic trig function. So that's a fancy way of saying a single trig function. So once again, I'm going to multiply each fraction by its own conjugate. The conjugates are different between the first and second fraction. The first fraction's conjugate is 1 plus sine x. The second fraction's conjugate is 1 minus sine x. So I'm going to multiply each fraction by the conjugate over the conjugate. In this case, I'm trying to remember if I combined the denominators or not. Well, I'm going to expose it and see. Well, first what I did was, it looks like, oh, I didn't want to move that one yet. It looks like I simplified the numerator, so it became 1 plus 1, which is 2, the positive sine x in the numerator and the negative sine x in the numerator subtract out to 0. So I'm only left with 2 in the numerator. I did end up multiplying 1 plus sine x times 1 minus sine x. Now notice, I wasn't sure what I did to get there. So there's a lot of times you're going to make mistakes and you're going to have to erase them and you're going to have to back up and you're going to have to try again. You cannot give up. A lot of times there's going to be a couple of brick walls you're going to hit before you get it right. So in this case, I did need to multiply the denominator. It simplifies to 1 minus sine squared x. I want a single trig function. So 1 minus sine squared x uses the Pythagorean identity. I can substitute cosine squared x. And as I said before, unless it says to, leave it only in terms of cosine, your final answer, you're going to want to get rid of the fraction and use your reciprocal identity and make the final answer 2 times sine squared x. Okay, last one. I am looking for a common denominator. In this case, I'm not using conjugates. I'm just trying to get a single common denominator. So that means since the second fraction has a denominator of sine x, I'm going to multiply the first fraction by sine x over sine x. The second fraction, I'm going to multiply by 1 minus cosine x over 1 minus cosine x. And already in green, I have what your next step should be, which should be to FOIL. So after I multiply 1 minus cosine x times itself, my numerator simplifies to be sine x times sine x is sine squared x. And then for my FOIL, I get 1 minus, there are 2 negative cosine x's. So the middle term, since I'm not multiplying by a conjugate, is negative 2 cosine x. And then negative cosine x times negative cosine x is positive cosine squared x. So if I look at my numerator a little carefully, I can see a Pythagorean identity. Again, addition is commutative. So I can put the sine squared x and the plus cosine squared x next to each other as, I have to move my window, hold on. There we go, you should be able to see it better now. And so therefore I can substitute sine squared x plus cosine squared x. The parentheses I have in blue, I can substitute 1 for that. So my numerator becomes, at this point, 1 plus 1 minus 2 cosine x. So 1 plus 1 is 2. I end up with 2 minus 2 cosine x. Notice, again, I did not multiply the denominator. I left it in fraction form. That's because if you look at 2 minus 2 cosine x, I can factor out a 2 and notice that I have a 1 minus cosine x factor in the numerator and a 1 minus cosine x factor in the denominator. Those can divide out to 1. I'm left with 2 over sine x. Remember, it doesn't say to leave it in terms of sine, so I'm going to change that to 2 cosecant squared x. Please attempt your homework, and I hope this lesson helped, and I will see you tomorrow.